So we're going to stay in California. We're going to do a little quick tour in Napa County, and this is just north of the San Francisco Bay Area where we are today. We're also going to switch gears a little bit on like the overarching themes and tone of what we're talking about. It's more of a good news story than a concerning story. So Napa County, a number of years ago, even in its general plan in 2008, it was talking about sustainability goals. So it was related to conservation, surface water, groundwater, and monitoring. Sustainability was already part of the dialogue, but it didn't really kick in until later on. We started doing studies in 2009, one of which I'm going to talk about in a little more detail in a moment on hydro-geologic conceptualization. So as you heard earlier today, a key piece of the new SGMA Act. Also, surface water groundwater interaction. I'm going to talk quite a bit about that later in my talk, a very key piece of the SGMA Act. An advisory group was appointed in Napa County, Groundwater Resources Advisory Group. It was a 3-year term, met every other month for 3 hours at least, and then subcommittee meetings in between. And this group in early 2014 had come up with a multi-page sustainability objectives. They're not all quantifiable, but it was headed in the right direction and very aligned with where it needs to be today to go forward with SGMA. So the groundwater basins, the key one of interest here is the Napa Valley Subbasin, and this is ranked a medium priority, so it's subject to the Act. It's about 72 square miles or 46,000 acres, extends along a lengthy alluvial valley. The important thing here is as was mentioned earlier today, the medium priority doesn't necessarily connote a concern. It's just that groundwater is a very important resource to the county. So looking back in history, there's some excellent classical geologic work done in the county, as has been done in many other places in the U.S. Extremely good work. However, there's since been 5 decades of additional information. So this is something that we looked to do as part of the updated hydrogeologic conceptualization. So here you see one of the cross sections that was developed at the time, a more simplified view of the subsurface. Going forward, we use those 5 decades of additional drillers' reports, some 6,000 plus, over 1,000 of which we reviewed in great detail, did a lot of quality control and quality assurance. As you can imagine, the drillers' reports are not all equivalent in their quality. And there was a lot of iterating by senior geologists, who's also what I would consider a classical geologist. And here's the exact same cross-section location shown here. And you can see that there's a much greater level of complexity, and the important geologic features additionally identified were a number of additional faults. And so it's very important to have this basis and foundation for the development of models, the expansion or updating of groundwater flow models in order to adequately represent what's going on in the system. So from that information, we're now looking at water budgets and updating them. This is a slide that I've used to the public, where we've done a number of presentations and trying to convey to the public, this is information that we've updated. It's important that we know about the inflows and outflows from the system. There are many things that we need to track and that we need to understand, even recognizing that there are a number of uncertainties associated with those data. So the water budgets involve obviously more than the groundwater basin itself. There's watershed areas external to the basin delineation. So this is important, what we're looking at in the rainfall, the runoff, stream flow infiltration. There were county-wide watersheds where we had used watershed, subwatershed delineations to do root zone model in combination with MBK as part of some work related to the hydrogeologic conceptualization. And I'm going to talk about an example of the results of one of these watershed analyses that relates to the Napa Valley Subbasin. So this is just a snapshot of our results, and the important things that I wanted to highlight are key pieces. Napa Valley subbasin and this watershed has the benefit of being very precipitation recharge driven in an alluvial valley in this county. So there's over 400,000 acre feet a year on average. So a very high opportunity for replenishment of the system. The recharge that we computed with the soil root zone model that's on a watershed, subwatershed scale, that this is on average 70,000 acre feet per year. Now the range, depending upon the precipitation, the water year type, I mean, there was a wide range from about 8,000 acre feet per year to 185,000 acre feet per year. So this means that this area is also sensitive to stresses, both natural and man-imposed. So one of the other key components, and this is one that was previously estimated a number of years ago by others, is the pumping, which at that time was computed to be about 21,000 acre feet. This is one that we're in the process of updating as a result of all the Sigma work. So what we're doing is looking at a number of water budgets. We've defined a historical hydrologic period that spans about 30 years, and within this period we're selecting a number of different years to represent different water year types, drier years, critically drier years, normal years, and wetter years. And because of Sigma and the baseline definition of January 1, 2015, we're also looking at current year for 2015, and then we're also looking at projected conditions to the best we can. So some of the things that we're doing to refine the water budget is to look at what was done historically, what were some of the assumptions about land use. And here Napa County is fortunate. It doesn't have 200 commodities to work with. It predominantly has one commodity to work with. But there are variations in that one commodity, and what the grapes are used for what purpose, what price tag on a bottle of wine, and what they want to do. But there are other changes in irrigation methods, newer technologies for actual evapotranspiration measurement with sensors above the plant canopies, variations geographically around the valley floor, looking at temperature differences and whether or not there's frost control. So we're trying to use GIS spatial analysis to get more refined, more definitive about all these different variables just related to the consumption by grapes. So the county has a monitoring network. This has been expanding over the past few years, including an effort through this Groundwater Advisory Committee where the committee went out and did recruitment of volunteers. And initially there was sort of skepticism even amongst the Groundwater Advisory Group. Some of the growers thought, no, nobody's going to want to volunteer up their well to be monitored. But in the end, they became advocates, and they reached out to their peers, and they recruited more wells, and we had about 48 volunteered wells. And this has complemented other monitoring that's been done for decades. So it's heightened the interest of the public, and there's another piece that I'm going to mention later about the public's engagement on, an interest in water level monitoring also. So groundwater conditions on the whole are quite stable in Napa Valley. These are 3 representative monitoring wells from north to south in the valley floor. Fortunate to have decadal monitoring associated with these wells, and excepting for dry years where we see dips, and the red bars represent the drier periods. We see a dip, and then we see a recovery and replenishment, and we see stable conditions. It's not that way everywhere. There are areas where we see local indications of greater stresses due to drought, more pumping locally, more in consolidated rock type, deeper cones of depressions very locally, where there's just a longer time to replenish. So depth to groundwater overall in the Napa Valley floor, this graph or figure shows it's very shallow. So the darker blue represents depths to water of 10 feet or less. And so in essence, most of this basin is quite full. Along the valley periphery, we have some warmer colored tones, deeper depths to groundwater, And here's where wells are completed in both the very thin alluvium, but also more consolidated rock. So more of a time frame to accomplish recharge to those systems. So quickly, one of the slides that's been useful to describe to the public is the differences in confined and unconfined systems and how you can have wells immediately adjacent to one another representing very different groundwater conditions. So we have that situation going on with a new set of monitoring facilities in the past almost 2 years now, for a surface water groundwater monitoring project supported by DWR grant funds. So they're at 5 sites, monitoring wells installed along with, these are coupled with surface water monitoring systems. Each stream gauge and monitoring well is equipped with transducers, so we're collecting data continuously. The monitoring wells at the 5 sites are nested, so there's 2 wells at each site. This is also another useful slide in terms of conveying this to the public, relating back to the other slide that described the unconfined and confined systems, because it's sometimes not understood how this can mean so much in terms of having very definitive information and the importance of understanding how these wells are completed in the aquifer system and what the data mean. So at one of these sites, as an example of that, we have sometimes surface water and groundwater connected and sometimes not. In December 2014, we had the condition where groundwater levels were above the Thalweg, the base of the stream bed. And then earlier that year, in October 2014, we had a disconnected system, so water levels were below the stream bed. The very interesting thing is that we had a head difference between these 2 monitoring wells of 15 to 20 feet. And the one shallower well is only 50 feet deep, and the deeper of the 2 wells, which is not that deep, is only about 100 feet deep. So it was surprising to see this much confinement and this much difference in these wells. So a little bit of context, we have the river monitoring a couple hundred feet, the groundwater monitoring a couple hundred feet from the river, an active supply well about 100 feet from where we've installed these groundwater monitoring wells. And we can see what this means in looking at data. So here we're showing the river in the darker blue, the lighter blue, the shallowest monitoring well, and those are tracking simultaneously together in response to precipitation events. And then we have the deeper monitoring well, which is only 100 feet deep, but it's reacting to the water supply well pumping in close proximity to it. And we don't see this response in the shallower monitoring well or in the river. So it's been very helpful. This slide shows one of our new sites, but it's also fortunate that near to this location, we have the benefit of a monitoring well that's been monitored by the county. It's an existing supply well, but only 120 feet deep. And it's only monitored twice a year, but we have a decadal-long record to be able to relate to what's going on at this newer well. So we see just at the tail end of this slide on the far right-hand side where we have a shallow and deep response that's similar to what we're seeing in these new monitoring wells. So from that, we can understand that the dry stream bed condition that we see for a period of a few months, that's not a new condition. That's something that's happened for many, many years. And so it's really important in terms of establishing what the baseline is, what we're talking about when we're trying to define measurable objectives and undesirable results in the context of a baseline condition and, what the county, the community, want to see going forward. So next steps, we're working on continued understanding of the surface water groundwater interaction and the data that we're gathering. There are plans for a groundwater model update. This would be a major update. There are interest in looking at grant opportunities through DWR and the State Water Board, and this is one of the possibilities is recharge areas along the periphery of the valley or elsewhere where it's conducive. The county is very active in public education and outreach, and one of the things that's pretty exciting that they've started doing, and they've got a lot of traction, is the public is very interested in a loan out sounder system where they have at the library sounders, and they call this project the Well-Being. And so they've gotten a lot of the public interested in measuring their own water levels. So it's not necessarily that the county is going to use these data, but they're heightening public awareness through this program. And then we're working on our water budgets. So that wraps it up, and just what the county does here. There's been a lot of changes over many decades. The Napa River system has obviously changed. We're not necessarily looking to go back to a pristine system, but it's up to the community, including the ag community, to know what it wants to define to be sustainable. Thank you.
And we have time for a question. Does anybody have a question for Vicki?
So the question is, under Sigma, the management institutions have to be developed by mid-2017. How is that institution building process looking in Napa Valley? Is it going to be one sustainability agency or a patchwork quilt with integration agreements?
What the county is looking at right now, and I don't know how much has been described early in the conference, but they're looking at an alternative. So it's a basin analysis report if the county can demonstrate that it has operated within sustainable yield for at least 10 years. And so that's the conditions that they're looking at now. They're looking ahead to even doing a groundwater sustainability plan within the time frame that others are doing it. But there was a lot of interest by the County Board of Supervisors and the water planning, the county's planning group, to do something sooner than later. So they are working towards doing a basin analysis report. So they're not looking to form a GSA immediately. What they are looking at is continued public outreach. They have a watershed information and conservation council. They do regular meetings. They do many, many kinds of outreach, public forums, town hall. So they felt that bringing on a GSA was another level of governmental effort and cost, that they would rather invest that into the technical work and then go forward.